Hello Year 11 Triple Biology. You will need your microorganisms and their applications booklet in front of you. Please turn to page 18. The lesson today was supposed to be a practical task, looking at numbers of bacteria in milk kept at different temperatures. Unfortunately, you will be unable to carry out this particular practical. It uses an indicator. Now, you've come across several different indicators at Key Stage 3. So we've used litmus indicator, you made red cabbage indicator, we've used universal indicator. This particular indicator, Rezurin, is an indicator of oxygen levels. In solutions with very high oxygen content, it is a purplish blue colour. It then changes to pink and then through to colourless to white as oxygen levels decrease. So we can use this indicator, to look at levels of bacteria in solutions, because as bacteria use oxygen for respiration, it can be used as an indirect measure of bacterial numbers in milk. It won't tell us the actual numbers of bacteria, but it will give us a good idea as to how much decay and decomposition of the milk has occurred. So in terms of apparatus, you will need a test tube rack, 4 test tubes, some sticky labels or a waterproof marker pen, a beaker, preferably about 250 cubic centimetre one, thermometer, tripod, gauze, Bunsen burner, heat resistant mat, and 4 lots of milk samples that have been labelled with the temperature at which they were kept. You'll also need some of the Rezurin dye solution. So just to give you a little bit of context, the older milk gets, bacteria grows in it and it starts to go off, and that's why you get that horrible smell to milk as it sours. The bacteria that are growing in the milk, making the milk go off, respire using up oxygen and the lactose, which is the sugar in the milk, turning it into carbon dioxide and lactic acid. That's why the milk tastes sour, because it's got this lactic acid in it. Rezurin is a chemical which detects the amount of oxygen present by changing colour, and so I will show you the different colours in a second. So you're going to be provided with samples of milk that have been kept at 4 different temperatures for the last 3 days. You're going to add a sample of milk to a depth of 3 centimetres to each test tube. This is to make it a fair test, so this is one of our control variables. You're going to label the tubes with the temperature at which the milk has been kept, and I will tell you what those temperatures are in a second. You're going to fill a beaker with about 100 cubic centimetres of tap water and stand the test tubes in this beaker. You then heat this over a Bunsen burner to around about 60 degrees Celsius. The Bunsen is then turned off. Carefully lift the beaker off the tripod and you put 6 drops of the Rezurin indicator in each test tube of milk, and you shake thoroughly with a kind of side-to-side action. You leave for about 15 minutes and you note any colour changes. So, interpretation of the results, we can see like a sliding scale here. Where it's quite dark purpley colour, it means that the milk is quite fresh and there are very few bacteria. As it starts to change through to mauve and pink and finally to colourless to white, it shows you an increasing number of bacteria. So the first thing I would like you to do, if I go back a couple of slides, pause the video, I would like you to write the apparatus. I'd like you to write a prediction about what you think is going to happen to the number of bacteria in the milk as the temperature increases. And we're going to go from 0 degrees up to around about 60 to 80 degrees Celsius, I want you to identify for me what the independent variable is in this investigation. What are we changing? What the range of the independent variable is and the interval, you'll see that in a second when I go over it. The dependent variable, what you're going to be measuring, and this is a categoric variable, and the control variables, what you will have to keep the same to keep it a fair test. So you can pause the video, you can rewind the video, so that you can see apparatus, as we said, the context to give you a little bit of the information to help you write your prediction. procedure in terms of the method, that is for page 19. So I want you to write a step-by-step plan of how to investigate bacterial populations. So you've got pages 18 and 19 to complete using what I've shown you so far. Pause the video and complete those pages. So in terms of results then, the colours that we would see, okay, if the milk quality was excellent, in other words, it was completely fresh, no bacteria, it would be this lovely blue colour, this azure blue colour. It starts to turn a kind of blue to mauvey colour. The quality of the milk would be good, it'd still be fine to drink. Mauve to pink is just starting to be on the turn, okay, it's fair, it's okay. Pink to pale pink would be poor, and if it was completely white, it would be bad, okay? So if I give you some results, this would be on page 20. You've got an area to record your results in to design a table. I've given the table 3 columns because I've said the temperatures, the colour of the Resorin, and the quality of the milk. And the range of the temperatures, I've gone from 0 degrees Celsius, okay, up to 60 degrees Celsius. Now, it wants to know what the interval is. I've purposely gone from 0 to 10 because 0 would be in the fridge. 10 would be just a little bit above perhaps fridge temperature. 30, okay, would be coming up to almost body temperature, and 60, obviously very, very high, okay, the quality of the milk, and a very, very high temperature. So we've got the colour of the Resorin and the quality of the milk. So complete your table, pause the video. So there are some questions underneath the table that you've just drawn out, okay? Describe the effect of temperature on the numbers of bacteria and how you can tell this. This experiment could be improved in several ways without completely redesigning the basic method. So see if you can think of as many improvements as you can, okay, to jot down on the dotted lines in the space on page 20. Obviously, this experiment doesn't give us any idea of the actual numbers of bacteria. It is merely a comparison. So how could you establish the numbers of bacteria in the milk at different temperatures? Well, if you've watched the link at the top of this page at the beginning of this lesson that looked at how you plate out the milk to count the numbers of bacteria and how we look at dilutions, okay, that should be able to give you a little bit of an idea. Pause the video and answer the questions 1, 2 and 3. So in terms of answers, as the number of bacteria increase, okay, or the number of bacteria increase as the temperature increases, and so you get going through from the blue to the purple to the pink to the white, okay. Possible improvements could include using a measured volume of milk rather than 3 centimetres depth, actually measuring the volume precisely. Keeping the milk in locations in which the temperature is controlled, because the temperature may change during the day, especially in winter time. Timing how long it takes for the Resorin to turn pink or colourless. So this might distinguish between 2 samples which both turn colourless within 15 minutes, but one may take less time than another. So if one takes less time, it has less bacteria than the one that went quickest. So if one takes less time to turn colourless, okay, it has more bacteria in it than the other one. Create a colour chart using standard solutions, so you could hold the test tube up against the colour chart and match it after 15 minutes. This is quite complicated, but it is possible, okay? And there are pieces of equipment that will actually measure, okay, things like the colour of solutions, okay? And also how cloudy a solution is, okay? And for question 3, you could take a sample of a known volume and spread it on an agar plate to count the number of colonies formed. So if we did number 3, if we actually took some of the known volume of milk, we spread it on an agar plate, and then we allowed that plate to incubate, okay, to grow up the colonies, this is the type of data that you might see. So I've given you a range of temperatures from 0 all the way up to 78, okay? So it goes up 8, 18, 28, 38, 48, 58, 68, 78, okay? So going up in intervals of 10, apart from the first one going from 0 to 8. I've put the number of bacteria per cubic centimetre of the milk after 25 hours, okay? So this has been diluted, this milk, okay, in order for us to be able to count the bacteria properly. So I've given you a copy of this Excel spreadsheet, okay, on Moodle. And what I'm hoping you can do is that you can produce me a graph on Excel, okay, to show this data. And then I will go over what the graph will look like and what we can see from those results. So pause the video, find the Excel spreadsheet, okay, on this, and use that to create yourself a graph. Make sure that you label the axes on your graph, okay, and you give it an appropriate title. Pause the video. So hopefully you should have a graph that will look a little bit like this. You may have chosen different designs, okay, based on the options that you're given on Excel. So it was up to you to choose whatever you wanted. Key points that I do want on your graph though is that I want you to have labelled this bottom axis, this x-axis, okay, the temperature of the milk, and don't forget to have included the units at degrees Celsius. So we've got from our 0, our 8, our 18, 28, 38, 48, 58, 68, 78. I purposely didn't give you bang on the 10s, 10, 20, 30, 40, 50, 60, because when we get you to graph this, normally on graph paper, I want to know that you can actually read off on your scale where these points are. Up the side, your y-axis, okay, should have the number of bacteria per cubic centimetre after 25 hours. And hopefully you've got a nice plotted line. So we can see at 0, okay, we wouldn't expect there to be many bacteria at all, okay. The level is so low you can't see it, okay. The number starts to increase as the temperature increases until it reaches a maximum at around about, okay, 38 to 40 degrees Celsius here. After that time, the number of bacteria will start to decrease, okay. This is because even though the temperature is warmer and bacteria like warm conditions, most bacteria will start to die off and don't like it really, really hot, okay? So this is why milk is what we call pasteurized, okay? So pasteurized means it's taken to very, very high temperature and very high pressure, okay? In order to kill any bacteria that might be in the milk when it's first been collected from the cows, when the cows have been milked. But obviously, as bacteria gets older, milk will get contaminate. The bacteria will contaminate the milk that you have, okay? And if it's left out in the warm, that will happen at a faster rate, okay? So you can see the number of bacteria per cubic centimetre of milk there. So that is the end of our lesson today. We'll be looking at dilution technique next lesson, and hopefully the video that you've watched today at the start of this lesson will help you with that work and counting bacterial colonies. Thank you, Year 11.